In this video we are going to derive the matrix form of the least squares estimator. We've already set up the model and got a set of partial derivatives with respect to each of the parameters, and we've set those partial derivatives equal to 0, which gives us a set of first order conditions. Now we can take those first order conditions and we can write them as follows. From the first we have the sum of y equals n beta hat 1 plus beta hat 2 times the sum of x2 plus beta hat 3 times the sum of x3. From the second we have the sum of x2y is equal to beta hat 1 multiplied by the sum of the x2's plus beta hat 2 multiplied by the sum of the x2 squareds plus beta hat 3 times the sum of the cross products, i.e. xi2 times xi3. Then from the third first order condition we have the sum of xi3 yi equals beta 1 hat times the sum of xi3 plus beta hat 2 times the sum of the cross products, xi2 multiplied by xi3 plus beta hat 3 times the sum of xi3 squared. Next we're going to show that we can write the least squares normal equations in matrix form. First of all we define a vector y which contains the observations on the y variable. Then we define a matrix X whose columns will contain the data for the X variables. The first column is a column of 1s corresponding to the intercept, and then the second column contains the data for the X2 variable, and the third column contains the data for the X3 variable. Next we define a vector beta hat which contains the three least squares parameter estimates, beta 1 hat, beta 2 hat and beta 3 hat. Now let's consider what happens if we take the transpose of X and multiply it by the matrix X. So we take X transpose X. That will give us a 3 by 3 matrix with the following elements: n, sum of x2, sum of x3 in the first row. Then in the second row we'll have the sum of x2, the sum of x2 squared, and the sum of the cross products x2, x3. And then finally in the third row we have the sum of x3 and the sum of the cross products and the sum of the x3 squareds. Next consider what we get if we multiply the transpose of X by the vector Y. Doing this we'll get a 3 by 1 vector whose elements are the sum of the Y's, the sum of the products of x2 and y, and the sum of the products of x3 and y. And using these we can write the least squares normal equations in the form x transpose x multiplied by beta hat equals x transpose y. So we take the normal equations and we've written them in matrix form. And this suggests a solution. If x transpose x is invertible, then we can derive beta hat as x transpose x inverse multiplied by x transpose y. And this will only be the case if the x transpose x matrix is invertible.